Okay, so we're going to have a go at the your turn question here, which is as follows. So it's another projectile one. We have an initial velocity at the top here of 612. We've got that it goes through this point here, and then something a little bit different, a bit more interesting on this one, which is that the distance from here to here is 2 times this distance. So it's like, I'm just going to write that. Okay, so that's what it's telling us. And that's more or less it. So it helps if we remember that we actually know the acceleration, first of all. And then what does it want? It wants the value of t. So this seems quite tricky, doesn't it? Because it seems like we don't have enough. We've only got 2 things here. So probably, and it's 7 marks, probably we want to use this one. So I'm going to do a slightly different way this time. I'm going to break it down as we did. So a little reminder of chapter 6. One way you can do these questions is like this. So you can say that the speed was 6 on that one there. And it was 12 for the u value there. This was minus 9.8. That's all I can do for that bit, isn't it? I think, yep. So the 2x and the x bit is going to be the clever bit now. So horizontally, it's gone twice as far at some value of t that we don't yet know. Whereas on this one, it's gone x meters above the ground in the positive direction for the same t value. So when you've only got 2 bits of information with projectiles, it means you have to do simultaneous equations, which is what you can see there. So let's write some equations now. So 2x is going to be equal to 6t, because distance is speed times time when there's no acceleration. This one here, we're going to do x equals ut, which is 12t, and then half at squared is going to be this one here. And what do we want? We want the figure of t. So if we double this one, 2x will be equal to 24t minus 9.8t squared. We can now set these equal to each other. So 6t equals 24t minus 9.8t squared. 9.8t squared minus 18t equals 0. T equals 0 is not one that we are interested in this case. When you solve it, have I got the number here somewhere? I've got 18 over 8. No, I haven't. I've got 18 over 9.8, sorry. Or, what's that? 1.84 seconds. Okay, so that's how you do the first bit. So when you've got 2 bits of information in the SUVAT with the projectile, it's a giveaway that you've got simultaneous equations usually. That's what I'm going to say there. And personally, I think it's quicker to just break it into the I and J parts and bring them back together later if you need to. What's the speed when it goes through A? Okay, so the speed horizontally will be 6 because it doesn't change because there's no acceleration. So what's really asking me is what's going on vertically here. So let's just work with the vertical because I don't need anything else. I'll put the 12 and the minus 9.8 in first, and I'll use the t value, I think, because there's no need for me to find s, I don't think. So I'm going to use 1.84 there, and then I'm going to find v, and I'm expecting v to be a negative number because it looks as though it's going down. So if you work through that one there, hang on a moment, I'm just trying to find that one here. So apparently you get minus 6. So what would I be doing on that one there? Because I'm just working inside V, U, A, and T. Yeah. So I'm going to just do, U, what do I want to do here? U plus AT. So I'm just going to write the calculation there just so you can kind of follow if you want to see where that's come from. So if I do that, I get minus 6. So at that point, it's sort of going across as quickly as it's going down. So the speed, it did say the speed. So we want to just do 6 squared plus, you can put it with a minus if you want to, but there's no need. The minus is just about the direction. So if you do that one there, you get 6 root 2 or 8.49 meters per second. Because it's mechanics and stats and things, always safe to give the units. Sometimes they do penalise you about that. Right. And then finally, we're going to finish with sort of a bit of a special question at the end. So at another point C on the path, the speed of the ball is also v. So before I read the rest of it, let's just think about this. So there's another place where the speed is the same. The speed was 6 root 2 at this point here. So there's another place that does the same there. I wonder if you can kind of guess where that might be. So yeah, because it's ground to ground, there is some symmetry going on. What you'll do is eventually you'll find out that it's over here. And it might sound really hard, but there's a trick to this. So this diagonal is going to be made up of an across and an up, isn't it? But you already know that the across is 6 because the across is always 6. So the other number, if that's a 6, well, that also has to be a 6. So this point here that has the same speed, instead of 6 minus 6, which is what happened over here, this one has to be 6, 6. Why? Well, because the horizontal is fixed. So that's why this number is just going to be the opposite sign. That's the symmetry of the whole thing kind of being shown to you. So this here just means, v equals 6 rather than minus 6. That's what we have to work with. Find the time taken. Well, can you see that's actually going to be quite an easy question now? So all you have to do on this one here is one more final suvat, where you write down your minus 9.8. This was 12. You say that this one here is 6 instead. So that's the thinking is all involved in getting that number there, really. And then it just wants the time. Okay. So again, you're going to do one more there, and I'm not going to go through that whole bit with you. I'm just going to tell you that you will eventually get 6 divided by 9.8, I think it is, and you'll get 0.61 seconds. Okay, so that's one of these sort of slightly more creative questions that you sometimes get with the projectiles. So overall, it's a relatively difficult question because of the part A, but if your habits are good, you can get through it. And notice that I answered this whole question without any I's or J's. So if you want to see an I and J approach, just go back to the worked example before and you'll see an IJ approach instead.